beer, it's good for you.
Hello and welcome to the video. Within this video we'll be looking at how to set up your Brewzilla GEN 4 to avoid temperature overshooting, and at the same time explaining everything that you need to know about the wrap system's PID algorithm for brewing. So let's get started. Brewing systems incorporating what is known as PID algorithms is nothing especially new, but with Brewzilla GEN 4 you have a much wider amount of volumes that you can brew within one system than ever seen before in an all-in-one. So for this reason there really is the need to be able to tweak your PID algorithm to accommodate this, and thankfully Kegland have opened this up for the user. A PID algorithm is actually pretty simple stuff when you break it down. It incorporates three values that can be tweaked to avoid overshooting and to aid in heating speed, which are the P, the I and the D. If these values are well set, then you will heat as quickly as possible and totally avoid overshooting. Not that a small amount of overshooting is really a bad thing, as it will not really have any real effect in the main scheme of things, so please do not beat yourself up over small amounts of overshoot. The P coefficient, or the proportional coefficient, is your main setting, and in some applications is the only one of the three that's actually needed. This can also work for brewing and controls the amount of heating power, so by reducing it down you will heat with less power and effectively reduce overshoot at the sacrifice of speed. The I coefficient, or the integral coefficient, adds in extra power to compensate for time difference between your actual temperature and your target. For this guide we'll not be using the D coefficient, also known as the derivative, as this is not especially useful for brewing and is more suitable for distilling, which due to legal reasons I will not go into. It should also be understood that different equipment types will often use different methods of settings, so as such settings that work on one device type like wraps for example will not transfer over to other types of equipment and vice versa. Naturally my guide here is simply covering wrapped PID for brewing. Let's now look at how we get started. Firstly, add a common mash-in volume of water for your brewing into your system. This can be a mean average if you like, as long as it isn't super wide. To determine this for myself, I looked over my most recent recipes and went for 20 litres, and this was on the basis that I generally brew 1 keg batches. However, if you're someone who brews 1 keg and 2 batches for example, then you will need to do this test twice. You will then need to take note of the best settings for each and swap over as you brew. You should also add your empty grain basket and false bottom into the brewing system so that we are creating almost the same environment as your mash, just without the grain. Then set your hysteresis to 0, as if we are going to make this as accurate as possible, then this setting will not be relevant. Then, as you might expect, do switch on PID heating if it's not on already. Let's now start off with our proportional or P setting. A good starting point setting for when you have half filled your Brewzilla is 0.48 here. This applies to both the 35 and the 65 litre models. I am using the 65 litre model here though, so I am using less than half, so I will start with the lower value of 0.45. If you wanted to go in the opposite direction, then filling to 100% of your system, then a value of 0.68 is also a great starting point. Moving on now onto the I or the integral setting, a good starting point for a half-filled system is a value of 0.0020, but if you are at 100% of your system, then in this case a value of 0.0010 is the best starting point. But in my case I will go with 0.0025 as a starting point, as I am not halfway, and this setting works the opposite way in terms of its value, as you can see. I then left the D setting as discussed already, so here are my first test settings for a 20 litre mash in size. I then started off by heating to a low temperature and seeing how that went. By starting low we can use the same water to tweak, so I'm starting at 40 degrees Celsius. I am also running the pump as I would during the mash to create as close to a correct environment for testing as possible. So as you can see here we are overshooting, and this ended up by half a degree at the start, but very quickly stabilised at 40 degrees Celsius. Not bad, but like all tests it can be improved on and gives us valuable information for where to go with our improvements. After a little trial and error testing I went with a p-value of 0.425, and this worked out really well with zero overshooting for this volume in my environment. I then started tweaking the I coefficient to improve on heating speed and was happy with the level of 0.0023 by the end of my testing. That is not to say that I feel that this cannot be improved on, as I'm certain it can. My next tweaks will be during a mash though, but it is important to get as close as you can before tweaking during an actual brew as I see it, if needed. Please do feel free to use my settings as a good starting point if your average mash-in volume is around 20 litres, though it must be understood that brewing environments do have various variables, hence why generic settings are not such a great idea, and finding your own certainly is. Lastly, it would be really great if, as a Brewzilla Gen 4 community, we could share out settings for the benefit of all to provide good starting points to save people time. Please share with us your settings within the comments section of this video, remembering to include the mash water volume and your system's voltage. Personally, I live in Norway and the voltage here is 230 volts, but naturally this does vary and will have an effect. Why not have a look now and see what others have shared already? I do hope that you found this video useful, informative and interesting. If so, why not consider liking and subscribing? For further support you can join the channel's Facebook group, and if you would like to support the channel then check out the channel's merchandise store, as all profits go back into the channel. Until next time, happy brewing!